our dearest Georgia Maniati. She is a speech and language research scientist at Samsung Electronics. She specializes in text-to-speech, a subfield of artificial intelligence, focused on transforming written content into spoken words. Her speech is, "Our AI models are only as good as our data." Okay. Welcome, Georgia.
Welcome.
Thank you so much for the introduction.
The pleasure is ours.
Thank you.
Okay. So I like to say that I try to teach machines how to talk. While up until now, people had to learn how to program or navigate complicated user interfaces in order to work with computers, our world is now becoming voice first, which means that we will no longer need to start through complicated UIs, but we will just need to use our own voice, speak in natural language, and we'll be able to access all the vast information and computational power that the internet and the machines have to offer to us. So here I make a reference to a science fiction film. So that was only science fiction in 1968. It's a Stanley Kubrick film, and in that film, we have the first science fiction voice assistant. His name was Hal, and he could respond to the main character of the movie, the astronaut, and actually, just by using the voice, the astronaut could ask for any processes to be made, and Hal would respond. So that was science fiction in 1968. The movie was A Space Odyssey, 2001: A Space Odyssey. Today, we have already moved to this era, so most of us do have a phone that has a smart assistant, a voice-enabled assistant. Oh. Something went wrong. OK. So today, artificial intelligence models are transforming the way we interact with technology and with people. But what many people have not realized is that the success and the performance of these models rely on one crucial factor: the data these models are trained on. So actually, there are estimates that about 80% of the work and the time spent within any AI project is collecting and preparing data for the model to be trained on. But even if this is so prominent, we don't feel confident enough with our data today. So in a recent survey, only 7% of the organizations responded that they felt confident that they successfully managed their data. So in this talk today, I will argue that choosing good data for our models is about more than just accuracy. It is about representing and categorizing our world for these models to learn it. These models will eventually work in our world, and they will be interacting back with us, transferring ideas. So they will be choosing good data for them is, in a sense, an act of world-making. In this speech, I will argue that our artificial intelligence models are only as good as our data. So in order to do that, I first need to define AI. This word is hype. We have heard it many times today and yesterday. I will briefly guide you through history on how we went about collecting data in the language industry, as I come from speech and natural language processing industry. Then we will look together into how data look in the internet era, and what are the processes that people follow today to process them and use them. And we will look into the white guy problem, which is basically a data problem in AI, and some suggestions for the way forward. So first things first, artificial intelligence. So we use this term to speak about a way of programming a machine respond to data in a way that an intelligent being would respond to the data. How does this differ from traditional programming? So while in traditional programming, we know precisely the steps or the rules that lead to a solution, and all we have to do is to translate them into a programming language in order to enable the machine follow them. So if we think the example problem of trying to teach a computer how to play chess, we would need to find all the allowed moves per pawn, and maybe also some heuristics on how to win a game. And then we need to translate every single rule into a programming language. But if we do not know the rules that lead to the answers to our problem, or if our problem is very complex, we cannot do traditional programming. So in that case, we can do artificial intelligence. In today's paradigm, which is the machine learning paradigm, all we need to do in this case is gather a huge number of examples. Usually, we will need to gather the problem examples as well as the answers, and then feed all this large data to a model, and then learn the algorithm, let it learn the rules that govern the data. So if we were to program a computer to play chess through artificial intelligence, we would just need to gather moves, like actual games of chess, and all this data, have them train a model. So if you think about it, this is also the way that we learn how to acquire capability, through exposure to real-life examples, through trial and error. So that's about AI, and let's think about a very simple example I like to use from computer vision. So let's say that our problem is that we want to code a classifier of two kinds of fruit, just oranges and apples. So we want, at the end of the day, the computer to be able not just to see a series of pixels in looking at the image of the fruit, but be able to actually give it a label. So we will collect thousands of images of these two fruits, and then label each one of them with what it contains. Then we need to let the model, OK, of course, we need to choose the correct algorithm to do it, but it will all be tabula rasa if we don't use the data. Then we let the model figure out the rules that govern the data. The model will associate some features, like the color of the fruit, with the prediction. So in this paradigm, our data is all we know. It's our ground truth, and we just agree that this is the reality. So in creating the data sets, we create the limits of how AI can see the world. So in that example, if we only used red apples to train the model, and then at test time we had a green apple, we're not sure that it would correctly classify it. It might as well classify it as an orange or fail totally. So we need to remember that the breadth of training data is very important. Now I will just go back in time and just let you know that AI has not always been like that. At the very beginning, actually, it was expert-based systems in the 70s, and in speech recognition, that meant that people just used grammar and linguistic rules to be able to predict a sequence of words that were contained in a segment of speech. But this didn't work very well at runtime. So just in the mid-'80s, people started to calculate all possible situations and choose the optimal one. So that was when probabilistic approaches started to emerge. And in speech recognition, people would count the frequency of word appearances instead of using rules. So by counting the most frequent words, they could then predict what would be the next word. That was the case in IBM research. And then we have some very famous sayings, like at the time, data for the first time became a big thing, because all these probabilistic models needed to be trained on a lot of data. So there's no data like more data, or every time I fire linguist, the performance of the speech recognizer goes up, like emphasizing the shift of paradigm. Then with the internet coming in the 90s and today, we know that we don't have any problem of finding data, but back in 1985, people couldn't find text that was computer readable easily. So they would find whatever, even child's novels or manuals, technical manuals. IBM Research even used a lawsuit that was filed against them to train their speech recognition model. And that is when data started to be viewed as something completely neutral, and language was seen as neutral, and more data was good enough. But language is not neutral. It's not the same regardless where it is found. And actually, all accounts of language are accounts of time and society and culture. So today, with the internet, everything has changed. Data collection is usually just extraction from the internet. It's common practice to just scrape sites like Wikipedia or Google Images to get training data for NLP or computer vision algorithms. And then, of course, there's the companies that provide platforms, and they can use their own users' data that have an advantage on it. And then, in the supervised machine learning paradigm, we also need to give data labels. So as we saw with the example before, we need to annotate each example with what it contains, if it's an image, or likewise, if it's about text. How do we go about it? It's a lot of manual effort involved in this. So artificial intelligence is quite artificial. People have invented crowdsourcing. So we have platforms like Amazon Mechanical Turk that provide distributed workforce, and people can complete microtasks and assign tags to segments of text or images for the computers to be able to know what is contained there. Later on, platforms started leveraging their own users' data to have labels. So if you actually react with emotions in a Facebook post, you actually label the sentiment of the content of this post. So also hashtags in Twitter are also labels that are generated by users. And in 2023, ChatGPT was also used in order to create annotations for natural language processing for text data. And actually, it was shown that it was more well-performing and more consistent than human labels when it came to opinion-based labeling. So that's all about the data and how we gather it and we use it today, but I have some questions for you. Today, we mainly use internet data, but who produces this data? Are they produced by all the world equally? Are they representative of the populations? And can they be used to train models that will be fair to all people? And are language data that we collect here and there neutral? I will show some examples from natural language processing where things have failed to respond to these questions in a minute. So this is one of my favorite examples. It's already 10 years ago. In 2013, it was the first time that a model of meaning was trained in an unsupervised way on a corpus of 3 million words of Google News. So the model actually was trained by seeing the co-occurrences of words in sentences. And at the end of the training, the model had learned representations for its word. So actually, high-dimensional vectors, 300 dimensions for its word, which we call word embeddings. These word embeddings could then be represented in a vector space. So when researchers represented these words in the vector space, they discovered two important things. One was that words with similar meanings occupied similar parts of the vector space. And the other thing was that relationships between words could be captured by simple vector algebra. So man is to king. Yeah, this is a bit funny. Okay. Man is to king, as woman is to queen. And sister is to woman, as brother is to man. So actually, in this way, we were able to represent language in a vector space. And so the study of linguistics could be just translated into simple vector algebra. Let's see how things went. So a couple of other researchers started querying this model, word-to-vec model. So if we subtract man from king and we add woman, what do we get? And the vector representation we got was equivalent to that of queen, which means that there was the gender relation captured. If we subtract France from Paris and we add Poland, what do we get? And we got the equivalent of Warsaw. So the concept of capital city was also represented. But let's see what happened when people started to ask the model to produce a word by analogy. So if father is doctor, then mother is, and the equivalent vector was nurse. I would have expected doctor. So if man is computer programmer, what is the equivalent for woman? And the vector was homemaker. So the model was terribly sexist. And it was trained on the Google News corpus, which was not just biased random data from Twitter or from hate speech. It was kind of journalist language, but language is already sexist because it has evolved in societies that have been like this. So the stereotypes that was present in language were automatically learned by this model. Now, if this model is used then to help improve results in Google search, for example, or in machine translation, it could perpetuate the biases and the sexism further. Second example. 2015, Amazon realized that a system that they had been using internally to sort the CVs of candidates was discriminating against women. Let's see why this had happened. So the tool relied 100% on AI, and it would review job applications to identify top candidates to go to the next level for interviews, for example. The problem came from training data. Researchers had just used existing CVs for training data, but as reality was, engineers and software engineers were already just almost all male. The model had learned to penalize resumes that contained the gender woman, or had also correlated some other traits like specific schools that girls had attended and penalized these resumes. At the end of the day, the tool rejected candidates unfairly. So this is another example of the very early, let's say, use of AI models trained blindly on found data without being evaluated correctly to see if it contains biases. But this tool had been used for years before Amazon realized that it perpetuated this discrimination. And then an example from image and from computer vision. the ImageNet dataset is one of the most widely used and influential datasets in the field of computer vision. It has been used to train and to evaluate models for classification, object detection, image recognition. And this dataset was started to be collected in 2006, and today it has over 14 million annotated images of objects, people, and whatever. So these images, 14 million images, each of them is annotated by a human annotator on what it contains through Amazon Mechanical Turk platform. The problem is the lack of geodiversity. 45% of the data set comes from the US, but the US only represents 4% of the world population. And China and India together contribute to 3%, even though they represent much more of the world's population. And not only the geodiversity of the data itself, but it's also that the labelers, people who labeled the data, who assigned the classes what each image contains, were Western people. And let's see some kind of biased outcomes that have emerged from models trained on this ImageNet dataset. So these two images, they both actually represent brides. On the left side, we have a Western bride. On the right side, we have an Indian bride. But algorithms trained on ImageNet only would label the left one as bride, and they would typically say that the right image contains costume. So another case why data should be looked at with more care. And then, as I am a linguist at heart, and I started from linguistics, being here and working in natural language processing and seeing the way that supervised models are now heavily reliant on data-hungry models, and the machine learning paradigm actually needs huge amount of data for anything to be trained, I can't help but remember that the internet data are actually produced by 10 different languages. But in the world, there is about 6,000 to 7,000 languages spoken. So most of the world's languages are low source, and they are not served by this paradigm of developing machine learning models. Actually, for these words, speakers may not have access to basic language technology like spell checking and internet search in their native tongues. And eventually, these people will become bilingual because they will start speaking some other lingua franca, like English, that allows them to access the internet. And most of the world's spoken languages will eventually fade. All these are examples of what we call the white guy problem in AI. According to the World Economic Forum in 2018, out of the AI experts employed worldwide, 78% are male, and only 22% are female. So AI teams have historically been dominated by one demographic group, and this group is men, and they have all been sharing the same education and working in the same companies, so they share one viewpoint of the world. The data are not broad enough. If we just look in the internet for data and we think that we're creating models that can address anyone, this is not quite the case, because internet data mainly represent languages and populations that have most commercial, let's say, interest and advantage. So there is a lack of geographic and linguistic diversity. And if you also think about generative models like ChatGPT, you can see that in the future, the internet will start having more and more resources in these languages, because now we have had the natural language resources, but now with great speed, we can populate the internet with more generated resources. So the underrepresented languages will become even more minority, and same goes for underrepresented worldviews and underrepresented people. But it's not just about the source of the data, as also the classes that we use to classify this data. Because if we do supervised machine learning, we need to define the classes. We saw the example with the brides, that, OK, the class bride existed, but it was not quite successful because the labelers had only labeled Western brides. So classes reflect worldviews, and also labeling data is subjective. So in this sense, artificial intelligence shapes the way that these models see the world, and the perspectives that are embedded in the training data will shape how these models will function within the society, and will feed the society back with ideas that will impact the real world. So some suggestions for the way forward. So apparently, the first and foremost is that we need to promote diversity and inclusion in artificial intelligence teams. We need diverse worldviews in designing AI systems, because this is the only way to reduce unfair algorithms and be able to think about choosing, collecting, labeling more data, but also, in this case, we can also think about starting to consider algorithms that will also be respondent to low-resource languages, for example, and alter our technology to accommodate more worldviews. Then, of course, we have to have evaluation that should be strict and good enough before any system is deployed. So the example with the Amazon CV sorting system could have been not have happened if the company had some culture of evaluating the systems before usually using it internally. So do not deploy before assessing the risk of bias. Then I personally believe that encouraging participation in AI education should be top priority. So AI shapes the world in very fast speed, but our education systems are still coming from the past. So children, as well as adults, are users of all these systems. So if we are better equipped on how to know that these systems are trained to mimic some data and they may contain biases, we are better off using them, knowing the limitations. So AI literacy is one key component that should be contained in education. And of course, initiatives to promote diversity, fairness, and transparency in the way that teams acquire and use data. So recently, OpenAI never actually responded to researchers when they were asking the exact data sets that were used for training ChatGPT. So data should not be seen as a competitive asset for a company, but we should be completely open on what has been used and transparent to ensure that all practices have been followed and the data has been acquired in a lawful way. So addressing bias and lack of diversity is key to mitigating the white guy problem in AI, which is mainly a data problem. So in this talk, I tried to start by demystifying AI and defining it as a way of programming with data. Then we saw briefly how data was not a big thing in the 70s, but with this shift in paradigm, it's the #1 thing today on how AI works. And then we saw some examples of how things can go wrong with data from the internet if we use them without really thinking about it, and some suggestions for the way forward. So thank you very much.
Thank you so much for the excellent presentation. Very interesting. Of course, biases are key to AI and decision making in AI systems. If you have the wrong data, you produce the wrong results, and if you influence decision making, that could lead to security issues as well, right? And lives. We've seen that actually. There have been accidents.
As a woman in this industry, when seeing the invitation, I needed to talk about this because I feel there is not enough realization about how data shapes reality, and feeding the world back with all this is only going to make these differences larger if we don't think well enough.
But do you think it's going to happen? There's going to be regulation
I think that awareness is now starting to be more and more developed. And, for example, we have the EU Act for AI, but regulation is always one step behind. So there should be some way for these big companies to be more transparent and not have data as an asset, because their models actually shape lives, and
because it seems that the business drive and the competition between companies makes AI feel as the Wild West. Everybody tries to compete and
publish without evaluating risks.
Go fast and see how.
So I think if we just start examining today's models and trying to locate the biases that exist today, tomorrow we'll be better prepared for new models.
We have just one question, time for one question, so we'll get with the high-voted one. Are there any recommendations on how to collect language-specific data?
Language-specific? Do we mean one language-specific or just natural language data? Yeah. Okay, so there is some open data sets that are published in open SLR, open speech and language resources, and these data sets are good enough for using them for training models. They're already collected, annotated, evaluated, and they have been used in the community, so maybe someone could start from open SLR. Yeah.
Okay, great.
Yeah.
So you will be available if someone wants some extra questions, because we have some questions and the time is pressing. But thank you so much.
Yeah, thank you so much.
This is for you.
Great speech.